Hello friends, welcome to Center for Civil Engineers. In this video, I am going to explain leveling problem. See, in this problem, all the values which are taken on a continuously sloping ground at an interval of 30 meter. Here you can see the list of the values which were taken on the continuously sloping ground. See, from this value from 0.7802, the last value is 2.545. And the reduced level of first point A was 180.750 meter. This is the value, and rule out a page of level field book and enter the above readings. Okay, we have to draw the pro forma of level page field book and then we have to enter all the values. Then calculate reduced levels of the points by a rise and fall method. Also calculate the gradient of line joining from the first point to the last point. Okay, this is about the given problem. Solution. If I draw the diagram like this is the continuously sloping ground. The diagram will be like this. So this is the instrument position, tripod. This is leveling instrument, and here this is the line of sight. This line of sight passes straight line like this, and this is the benchmark. This benchmark value is given in the problem, that is 180.750, 180.750, and this reading nothing but 0.780. That is first reading, and this is second reading, third reading. All these values nothing but intermediate values. This reading nothing but 1.535, and this one is 1.955 and 2.430, and this one is 2.985, and this one is 3.480. If you observe all these values up to here, all the values are increased gradually. After this value 3.480, suddenly the value is changed from this value to this value. See, this is less value. Okay, that means after taking 3.480, suddenly instrument is shifted from first position to second position. For example, like this. This is the second instrument station. That is, the value over this point is nothing but this value 1.155. Okay, see this we don't have the value line like this. Up to here, these are the values. These are the values. Okay, this reading nothing but this one, and after that again values taken like this continuously. Okay, see, after maximum value, that is 3.48, the instrument was shifted. That is, this is nothing but change point 1, CP1 or TP1. TP1 stands for turning point, CP1 stands for change point. See, likewise, all these values were taken on the continuous sloping ground, and these values we have to enter in the tabular form in a first method, that is rise and fall method. We'll see how to enter in the given tabular form. Here, this is the given tabular form. Here you can see this is the given tabular form. Actually, I have drawn in advance. See, this is the station column. Station nothing but the point where staff is placed, not instrument. Where staff is placed, that is station. Then chainage. All these values are taken at an interval of 30 meter chainage. Chainage nothing but distance. This is 0, 30 and 60, 90, 120, 150, 180, 210, 240, 270, 300, 330. Likewise, all these values taken. The first value, simply if you observe all these values up to here, all the values are gradually increased. See, this is the first site, back site. We can blindly enter in the backside column 0.780, and this is the last reading from the first setup. Okay, this is nothing but Fs value, last reading. Between uh, Bs and Fs, all these values are entered in the intermediate column. So like this, 1.535, another one is 1.955, and 2.430, and 2.985, and after 2.985, Fs is last reading 3.480. This is 3.480, and this point nothing but change point. We have to write in remarks column CP1, change point 1. Okay, likewise first setup instrument value is completed, and this is after Fs immediate value is Bs. Again, if you observe all the values, see, increased, suddenly decreased. So this is nothing but Fs value, and this is Is, and this is also Is value. Now say all this already, this is backside. The in change point we have to enter two values in a same row, that is 1.155. Then these two intermediate site 1.960, 2.365, and this last one is Fs from second instrument station, that is 3.640. 3.640 is the Fs value. Then immediately after Fs, this will become 0.935 is it becomes backside reading, that is 0.935. Then this is intermediate site, and this is intermediate site, this is one is last one is 4 site. Okay, then now enter 1.045, 1.630, and the last reading is 2.545. Likewise, we have to enter all the values based upon the given values. Okay, here it is not given change points. Just by observing physically based upon magnitude of values, we can calculate, we can enter all the values in a given tabular form. It is this problem, this tabular form you are not going to get. You have to draw, you have to remember, and you have to draw the tabular form on your own. Then after entering all these values, next step is we have to calculate rise values. Rise value nothing but difference between the two consecutive readings. Two consecutive readings nothing but, for example, if I take these two values, I'm showing in yellow color. If I take difference of these two values, okay, that means 0.780 minus 1.535. If I get positive value, I have to enter in rise column. If I get negative value, I have to enter in fall column. Likewise, between two consecutive values, we have to take difference, and depends upon the sign. If it is positive, we have to enter in rise column. If it is negative, we have to enter in fall column. Like that, we have to calculate, and the reduced level at benchmark, that is over A point, is the value is 180 point. This is 180.750, 180.750. Okay, then if you subtract these two 0.780 minus 1.535, the value is 0.755. See, in first row we can't get any values, and between these two values we have to enter in a second one. Here we are going to get all negative values. Why? Because all these values were observed on a continuously sloping ground. That's why we are going to get the fall values. 0. First value is 0.755 and 0.420, and next one is difference of these two values. These two values is 0.420, and difference of these two values, 1.955 minus 2.430, you will get 0.475, and another value is 0.555 and 0.495, and difference of the up to here completed. Then difference of these two values, and this one is 0.805, 0.805 and 0.405, and difference of these two values is 1.275, and difference of these two values is 0.110, and another difference of these two values is 0.585, and difference of last two values 1.63 minus 2.545 is 0.915, 0.915. Like this we have to enter all the rise value, fall values, then we have to calculate reduced levels. Okay, simply how to calculate reduced level is simply this RL minus this value will give you the corresponding reduced level. 180.750 minus 0.755 gives the RL of second point, that is 179.995. Similarly, the same value from previous value 179.995 gives you 995 minus 0.42 gives you the RL of second point, that is second point is 179.575, and another one is 179.100. Simply this minus this minus this, and now 179.100 minus 0.555 will give you 178.545, 545, then 178.050 and 177.245, 177.245, and another value is 176.840, 176.840, and 175.565, 175.565. This is CP2, this is CP2 change point 2, and after this value 175.5, 175.455, and next RL is 174.870, and another value is 173.955. Likewise, simply by subtracting the previous RL minus next fall will give you the corresponding reduced level of that particular point. So likewise we have to calculate up to the 330 meters, that is last reading. Then we have to take summation of BS values. If you take summation of all these BS values, that means 0.780 plus 1.155, 0.935, it will give you 7 point, it will, and the total value of this summation is 2.870, 2.870. This is sigma BS, and the summation is 2.870, that is sigma BS. Similarly, sigma Fs is equal to 9.665, 9.665, and summation of rise values, here summation of rise value is 0 and summation of fall value is 6.795. Okay, likewise we have to take summation of BS and Fs and summation of rise and fall. Arithmetic check. sigma bs minus sigma fs is equal to last RL minus first RL sigma rise minus sigma fall is equal to last RL minus first RL. This is the formula. This is the arithmetic check. If you write all the values, the subtraction of BS minus FS value is 2.870 minus of 9.665 that is equal to 0 minus 6.795, and the last RL is 173.955 minus of 180.750. See, these two values subtraction is 6.795 meter and is equal to subtraction of these two values is, this is a negative value, again negative of 6.795 meter, and this one also 6.795 meter. Now, so all these values are equal, so this check is correct, check is okay or correct. Likewise, we have to apply the arithmetic check, and if you get all these values same, that means your calculations are correct. Okay. Likewise, we have to solve problem by using rise and fall method. Same way, by HI method, we can calculate reduced levels. This is HI method. See, already we know how to enter all these values in a table form. Then HI, the reduced level of the first point is, first reduced level given in the problem, that is 180.750. This is the benchmark, RL of benchmark. And HI is equal to RL of benchmark plus this backside will give you the RL of benchmark plus this side will give you, that is 181.530. 181.530. How you got this value? These two summation, 180.750 plus 0.780, and you got this value. Now next, to calculate reduce level of second point, just subtraction of these two values, 181.530 minus 1.535 will give you RL of second point, that is 179.995. 179.995. Similarly, this value minus this value, this value minus this value, this value minus this value. Likewise, we have to subtract up to the change point 1. When you change the point, when you change the instrument, you will get another HI, new HI will come. Okay, new HI we have to calculate in that case. Now, the third value is 179.575, 179.575, and the fourth value is 179.100 and 178.545, 178.545, and this last reading is 178.050. Now the instrument is shifted now, that's why new HI will come. This RL plus this backside will give you new HI. See, whatever I have rounded here, these two value summation nothing but a new HI value, that is HI2. HI2 is 179.205, 179.205. Now subtraction of these two values and this value will give you another set of reduced levels. Okay, that is Next value is 177.245, 177.245. Similarly, 176.840, 176.840, and at change point we will get the new value, that is 175.565, 175.565. This is third value. This is another value. Next, here we will get another HI, that is at change point 2 we will get another HI, that is 176.500, 176.500. Now from this, if you subtract this value and this value and this value, you will get other reduced levels like this: 175.455 and 174.870, and another one is, last one is 173.955. Okay, likewise we have to calculate all reduced levels simply by subtracting from HI with respect to FS and IS values. Okay, then again summation, we have to take summation of BS values and summation of FS values, and then we will get the arithmetic check. See, the total value of BS values is 2.57, 2. The total value of the total summation of this value is 2.8. The total value of sigma BS value is 2.870. Similarly, FS value is 9.665, and this is first RL and this is last RL. Now arithmetic check is equal to arithmetic check for HI method. Simply sigma BS minus sigma FS is equal to last RL minus of first RL. Sigma BS, you know, that is 2.87 minus of 9.665 is equal to last RL is 173.955 and minus of first RL is 180.750. From this minus of, we will get minus 6 points. From this we will get minus of 6.795 meters and also negative of 6.795 meter. Hence check is okay. Hence check is okay. Likewise, we have to apply arithmetic check. When you get both values LHS and RHS same, that indicates your calculations are correct. So likewise, we have to calculate HI method also. Last step is gradient. Gradient between first point and last point. Between A and B, that is first and last points. See, actually gradient nothing but, see, there are the total distance is around 330 meter. This distance is 330 meters. Okay, for 330 meters, how much fall of total is 6.795 meter. 6.795 meter. 6.795 meter. This is the fall total value. Okay, this is fall. That is nothing but continuous sloping ground. That's why we got this much of fall. Now the gradient is, how to calculate gradient is simply the total, there is a fall of 6.795 meters. Then gradient is equal to 6.795, that is fall divided by total distance 330. This will give you the gradient we have to mention like this: 1 in 48.56. So you can make it round, that is 50. The gradient is 1 in 50. For every 50 meter, 1 meter fall is there. That is the meaning of the gradient. Okay, that means for every 50 meter, horizontal 50 meter, 1 meter is fall is there. Okay, likewise there is a fall of 1 in 50. Likewise we have to calculate the gradient in case of leveling problem.
With this, I have come to an end. Thank you for watching this video. For more videos, subscribe to our channel and also share your valuable comments and follow me on Facebook, Instagram, LinkedIn, Twitter, etc. Thank you.